In this module, we're going to now use this knowledge of solving quadratic equations and use it to actually solve a real-life application problem. So if you look at your PowerPoint, here's my application problem. The length of a rectangular garden is 5 feet more than its width. The area of the garden is 176 feet squared. Find the dimensions of the rectangular garden. So that's a real-life word problem. We all know what a garden is. We all know what shape of a rectangle is. It wants us, the first thing we have to do is figure out when we read this word problem, what the heck do we want an answer to? And what we want to answer to is we want to find the dimensions of the rectangular garden. So anytime you hear the word find, that's telling you what you want an answer for. Now the word dimensions in English is plural, which means I don't want one answer, I want two. In mathematics, what we want to do right here is what step 1 says. When we read the word problem and we figure out what we want an answer to, we want to define words with variables. We want to write what we call let statements. So the first thing I'm going to ask you is, what does it mean by the dimensions of a rectangular garden? Well, if you look at a garden, that's a rectangle. We know the bottom of the garden is called the length, and the sides of the garden are called the width. And that's what we want to find. We want to find the measure of the length and the measure of the width. So we're going to write let length, let width. And we got to equal them, and we don't know what they are, so we want to use our variables. Now the problem is you can't call the width x and the length y. We can't use two different variables. You can't call them both the letter x, because that would imply they're the same measurement, which we don't know. So we're going to go read our word problem again. The length of the rectangular garden is 5 feet more than its width. Right there, you know something about the length. You know it's 5 feet more than its width. What you have no information on at all is its width. And the word, the concept that you know nothing about is the one that you call x. So now my let statement, I'm going to say let the width equal x. Every time I see the word width, I'm replacing it with x. Now the length is in math means equals. 5 feet more means to add 5 to the width. The width you called x. So we would say the length is x plus 5. So step 1 is when you read a word problem, define your variables. Did it. Step 2 is to reread the word problem now, and now we have to write an equation. Well, we've already used the first sentence. We're done with that. Sentence 2 says the area of the garden is 176 feet squared. What does the word area mean? Well, from geometry, area means you take the length and multiply it by the width, and it gives you the measure inside. And from geometry, we wrote a formula. A equals LW. Well, formulas are equations. Now, all we're going to do is replace those letters A, L, and W with the information we know. A is area, and we know it's 176. So we put that in that spot. L stands for length, and you just told me in step 1 the length was x plus 5. W is width. You told me in step 1 the width is x. And because L and W are connected by multiplication, that's why this parentheses around the x plus 5 and x. So now we have an equation. Step 3 is simple. Solve it. Now, if you look at that equation right now, it is not quadratic. There is no x squared. You cannot move the 176 yet. The first thing you have to do on the right side is multiply x plus 5 times x by distributing, and you would get 176 is x squared plus 5x. Now we have the x squared. Now it's quadratic. We want it set it equal to 0. So it would be really quick to set it equal to 0 by moving the 176 to the right. Now I know what you're saying. You're saying, Miss Black, but I thought we always move our terms with a quadratic to the left. But think about this. If you take that x squared and move it to the left, it's going to become what? That's right, negative. And we don't want our x squared to be negative. So it's quicker. Let's move the 176 to the right. We get 0 equals x squared plus 5x minus 176. It's still an equation, and it's still quadratic because it has the x squared. Now, I'm like you. I have a pet peeve. I don't want my 0 being on the left. I want my 0 being on the right. So I'm just going to rewrite that equation now. X squared plus 5x minus 176 equals 0. Same equation. Now I'm going to factor. I do not have a GCF. It's not difference of perfect squares. It's an easy trinomial. So x squared is x times x. Two numbers that multiply to 176 and subtract to 5 are 16 and 11. Now I have my two linear equations. I set them equal to 0. I solve. I get x equals negative 16, x equals 11. And that's where most of you stop. So most of you would tell me, okay, the dimensions are negative 16 and positive 11. And you're wrong, because you have to go back and read, and it has to make sense. Can in real life length and width be a negative number? No. So that negative 16 is a useless piece of information, so just throw it out. The x answer is 11. So now, to answer what the length and width are, you take that 11, because length and width can be positive, and you sub it in. Let width equal x. So the width would be 11 feet. Let length equal x plus 5. The length would equal 11 plus 5, which would be 16 feet. And that's your answer. The length is 16 feet, the width is 11 feet, and yes, if you multiply that, the area would be 176 feet squared. Let's go to the board.